September 15, 1942, North Africa. The sun blazed mercilessly across the endless expanse of sand and rock, creating shimmering heat waves that distorted the horizon like a desert mirage. Captain Marco Benedetti crouched beside his M13 tank in the scorching desert heat, sweat streaming down his face beneath his leather helmet as he watched his crew cheer with unrestrained jubilation. They were pouring captured American aviation fuel into their machine, with the reverence of priests handling sacred wine. The liquid gold sparkled in the afternoon sun like precious metal, each drop promising freedom from the chronic fuel shortages that had plagued their unit for months. The sweet, powerful aroma of high-octane petroleum filled the air, a scent that represented hope after weeks of desperate rationing. What these Italian tankers believed would be their salvation, their ticket to renewed combat effectiveness and pride, would soon become their mechanical nightmare, revealing a critical oversight that would expose the fundamental differences between Allied and Axis industrial capabilities. The desert had been unforgiving to both man and machine. For 3 weeks, Benedetti's tank company had subsisted on emergency fuel rations that barely allowed for essential reconnaissance missions. Their German allies, with their typical efficiency and ruthless prioritization, controlled the lion's share of precious petroleum supplies flowing through the Mediterranean supply lines. Italian units were left to scavenge what they could from captured Allied depots, abandoned vehicles, and the occasional supply convoy that managed to evade British naval interdiction. The situation had become so desperate that some crews were mixing captured vehicle fuel with alcohol and cooking oil, creating makeshift petroleum mixtures that barely kept their engines running. Before we dive into this story, make sure to subscribe to the channel and tell me in the comments where you're watching from. It really helps support the channel. This is the story of how one moment of battlefield triumph transformed into a lesson about the devastating power of industrial sabotage, forever changing how these soldiers viewed their enemy's technological superiority and revealing the sophisticated chemical warfare capabilities that American engineers had developed behind the scenes of conventional military operations. The Desert Campaign had been unforgiving for the Italian armored divisions since their arrival in North Africa 8 months earlier. The landscape itself seemed designed to defeat mechanical equipment. Fine sand particles infiltrated every moving part. Extreme temperature variations caused metal to expand and contract unpredictably, and the endless heat created operating conditions that pushed engines beyond their designed limits. Benedetti's tank company, designated as the second company of the 4th Tank Battalion, part of the prestigious Ariete Division, had been operating on emergency fuel rations for 3 weeks. Their situation reflected the broader logistical nightmare facing Italian forces throughout the campaign. The company's fuel consumption reports painted a grim picture of their operational reality. Each M13 tank required approximately 200 gallons of fuel for a full day of combat operations, including movement, engagement, and tactical positioning. With 30 tanks in the company, their daily fuel requirement exceeded 6,000 gallons under normal operational tempo. Emergency rationing had reduced this to less than 1,500 gallons per day, forcing commanders to make agonizing decisions about which missions could be supported and which had to be cancelled. Lieutenant Giuseppe Moretti, the company's youngest tank commander at 22 years old, had been assigned the thankless task of fuel reconnaissance. The officer from Naples possessed an engineer's mind and a mechanic's hands, skills that had made him invaluable for scrounging operations. His tank crew included some of the most resourceful soldiers in the company: Corporal Luigi Ferrara, whose family operated a garage in Milan, and who could identify fuel quality by its color and consistency; Private Franco Bianchi, a former petroleum worker from Sicily who understood the chemistry of different fuel grades; and Sergeant Antonio Rossi, a veteran mechanic whose experience spanned every Italian armored vehicle produced since 1935. When British forces retreated from their forward airfield near El Alamein following intense pressure from German armored units, they appeared to have abandoned their position in considerable haste. Standard British procedure called for complete destruction of fuel supplies, ammunition stores, and any equipment that might prove useful to enemy forces. Intelligence reports suggested that rapid German advances had disrupted British withdrawal plans, potentially leaving valuable materials behind. Moretti's reconnaissance mission on the morning of September 14th had initially yielded disappointing results. The main British supply depot had been thoroughly destroyed according to standard operating procedures. Fuel storage tanks showed evidence of deliberate sabotage, with explosive charges having ruptured the containers and ignited their contents. Ammunition bunkers had been collapsed with demolition charges, and communication equipment had been systematically destroyed with sledgehammers and thermite grenades. However, approximately 2 kilometers east of the main depot, Moretti discovered what appeared to be a secondary storage facility that British forces had overlooked in their hasty retreat. The site contained over 3,000 gallons of high-octane aviation fuel stored in pristine American containers, each bearing detailed specifications and quality certifications. The fuel drums were arranged in orderly rows, protected from sand and sun by camouflage netting, and showed no signs of sabotage or contamination. The discovery seemed too good to be true, and initially, Moretti approached it with appropriate military caution. His training emphasized that abandoned enemy supplies frequently contained booby traps, explosive devices, or chemical contaminants designed to eliminate unwary scavengers. Using procedures learned during advanced reconnaissance training, Moretti's crew spent over an hour examining the fuel depot for signs of sabotage. Corporal Ferrara, whose mechanical expertise had saved the company's vehicles numerous times, conducted a thorough inspection of the fuel containers. Each drum bore official American military markings indicating 100-octane aviation fuel designed for high-performance aircraft engines. The containers showed no signs of tampering, explosive devices, or chemical contamination. The fuel itself appeared to be of exceptional quality, with the clear, bright appearance and sharp, clean aroma characteristic of premium petroleum products. Private Bianchi, drawing on his civilian experience in Sicily's petroleum industry, conducted field tests using techniques learned from commercial fuel suppliers. He examined fuel samples for water contamination, sediment particles, and chemical irregularities that might indicate sabotage or deterioration. Every test indicated that the captured fuel was not only legitimate, but of higher quality than anything the Italian forces had used since arriving in North Africa. When Moretti returned to the company command post that afternoon, his report electrified the entire unit. Officers and enlisted men gathered around the intelligence briefing tent as the young lieutenant described his discovery with barely controlled excitement. His voice trembled with anticipation as he detailed the massive fuel depot, the pristine condition of the containers, and the exceptional quality of the aviation petroleum. "Captain, you must see this with your own eyes," Moretti said, his voice carrying the weight of a man who had discovered treasure beyond imagination. The British left everything behind, hundreds of fuel drums, all marked with American aviation specifications, the highest grade petroleum I have ever encountered in my military service. Captain Benedetti studied his young lieutenant with the careful attention of a veteran officer who had learned to balance optimism with military reality. The captain's weathered face, marked by months of desert warfare, showed cautious interest mixed with professional skepticism. Too many promising discoveries had turned into disappointments or disasters for Benedetti to accept any report without thorough verification. "Tell me exactly what you found, Lieutenant," Benedetti said, settling into his camp chair and gesturing for Moretti to provide a complete briefing. "Every detail, every observation, every test your crew conducted." Moretti consulted his field notes, written in the precise script he had learned at the military academy in Turin. His report demonstrated the thoroughness that had made him valuable despite his youth and relative inexperience in combat operations. The depot contains approximately 300 individual fuel containers, each holding 10 gallons of aviation petroleum. Moretti began, reading from his carefully maintained reconnaissance log. American military markings indicate 100-octane rating, possibly higher. The containers show no evidence of tampering, contamination, or deterioration. Corporal Ferrara conducted mechanical inspections following standard procedures. Private Bianchi performed chemical field tests based on his civilian petroleum experience. Sergeant Antonio Rossi, who had been maintaining equipment outside the command tent, entered to hear Moretti's report. The grizzled non-commissioned officer possessed more mechanical knowledge than most officers, earned through 15 years of maintaining Italian armored vehicles under impossible conditions. His calloused hands could assess mechanical problems through touch alone, and his nose could identify fuel quality with laboratory precision. "Captain, with your permission, I would like to examine this fuel personally," Rossi requested, his tone reflecting both respect for military hierarchy and confidence in his own expertise. "I have maintained tanks through every campaign since Ethiopia. I can determine whether this fuel will benefit or damage our engines." Benedetti nodded his approval, recognizing that Rossi's expertise was invaluable for evaluating any captured petroleum supplies. The sergeant's judgment had prevented numerous mechanical disasters when other units had suffered engine failures from contaminated or inappropriate fuel sources. The expedition to examine the captured fuel depot departed before dawn on September 15th, with Benedetti personally leading a convoy of 3 vehicles to assess Moretti's discovery. The captain understood that fuel quality could determine his company's combat effectiveness for weeks to come, making personal verification essential rather than simply delegating the decision to subordinate officers. The fuel depot exceeded even Moretti's enthusiastic descriptions. Container after container of pristine American aviation fuel stretched across the desert site, organized with military precision and protected from contamination by professional storage procedures. Each drum bore detailed specifications indicating fuel designed for high-performance aircraft engines, operating at extreme altitudes and temperatures. Sergeant Rossi examined one of the captured containers with the reverence of a man handling precious metal, his experienced hands testing the weight and balance of the fuel drum. The grizzled non-commissioned officer had served with Italian forces since the invasion of Ethiopia, maintaining tanks through campaigns in East Africa, the Balkans, and now the Western Desert. His weathered hands could assess fuel quality by touch and smell alone, skills developed through years of working with petroleum products of varying quality and origin. "This is magnificent fuel, Captain," Rossi reported after conducting his thorough inspection, inhaling the sharp, sweet aroma of the aviation petroleum with obvious appreciation. 100-octane rating may be higher. Our engines will run like thoroughbred horses with this quality of fuel. The American specifications indicate petroleum designed for maximum performance under extreme operating conditions. The excitement was infectious throughout the tank company as word of the fuel discovery spread through the ranks. Corporal Luigi Ferrara, the radio operator whose family operated a successful garage in Milan, calculated that the captured fuel would last their unit for nearly 2 months of intensive operations, assuming normal combat consumption rates. Staff Sergeant Enzo Lombardi, who commanded the company's supply section and maintained meticulous logistical records, estimated they had acquired enough premium fuel to power their entire tank battalion through the next major offensive operation. Tank commanders gathered around the fuel depot, examining containers and discussing the tactical implications of their discovery. For men who had spent weeks rationing every gallon of fuel, the sight of abundant, high-quality petroleum represented a transformation in their operational capabilities. Conversations buzzed with plans for extended reconnaissance missions, aggressive patrol operations, and renewed confidence in their ability to engage enemy forces effectively. What none of these experienced soldiers understood, despite their collective decades of mechanical expertise, was that American aviation fuel contained specialized additives designed specifically for aircraft engines operating at extreme altitudes and temperatures. The sophisticated chemical composition included tetraethyl lead compounds that enhanced octane rating for high-compression aircraft engines, anti-icing agents that prevented fuel line freezing at high altitudes, corrosion inhibitors that protected aluminum components from chemical degradation, and thermal stability enhancers that maintained fuel properties under extreme temperature variations. These additives, which enhanced aircraft performance under specific operating conditions, would prove catastrophically incompatible with Italian tank engines designed for entirely different operating parameters and manufactured with different metallurgical specifications. American petroleum chemists had developed this fuel formulation through extensive research and testing, creating a product optimized for aircraft engines that operated at altitudes exceeding 20,000 feet, where temperature and pressure conditions differed dramatically from ground-level operations. The specialized additives were precisely calibrated for engines constructed with specific materials and designed for particular operating characteristics. Aircraft engines use different metallurgical compositions, cooling systems, and fuel delivery mechanisms compared to tank engines, making their fuel requirements fundamentally incompatible despite superficial similarities in petroleum-based composition. The fuel transportation and distribution from the captured depot began immediately, with Italian supply crews working through the night to move containers to individual tanks. Each M13 tank received 40 gallons of the premium American aviation fuel, enough for 2 days of intensive combat operations. Tank commanders supervised the fuel transfer personally, treating the precious petroleum with extraordinary care and attention to prevent contamination or spillage. The first tanks to receive the American aviation fuel showed immediate and dramatic improvements in performance that exceeded every crew member's expectations. Engines that had struggled with rough Italian fuel, contaminated petroleum supplies, and makeshift fuel mixtures now ran with smooth, powerful efficiency that seemed almost magical. Tank commanders reported increases in maximum speed, improved acceleration, enhanced fuel efficiency, and smoother engine operation that transformed their combat capabilities. Benedetti's own M13 tank, which had suffered chronic engine problems since arriving in North Africa due to persistent mechanical issues and poor fuel quality, suddenly accelerated with newfound vigor across the challenging desert terrain. The engine that had previously struggled to maintain proper operating temperature now ran cool and smooth, generating more power than the crew had experienced in months of desert operations. Private Bianchi, whose petroleum industry experience made him particularly sensitive to engine performance characteristics, marveled at the transformation in his tank's capabilities. "Captain, this engine sounds like a completely different machine," he reported with obvious amazement. "The power output feels doubled, maybe tripled. We can climb steep terrain that previously challenged our engine capacity." Tank crews throughout the company reported similar improvements in mechanical performance. Lieutenant Moretti's tank, previously the slowest in the company, now outpaced every other vehicle in formation exercises. For 48 hours, the Italian tank company celebrated their extraordinary good fortune with the enthusiasm of soldiers who had discovered a miracle cure for their mechanical ailments. Tank commanders submitted glowing performance reports to division headquarters, describing unprecedented improvements in operational capabilities. Morning briefings buzzed with optimistic discussions about renewed combat effectiveness and aggressive tactical operations that had been impossible under previous fuel constraints. "I have never experienced such performance from these machines in my entire military career," Benedetti wrote in his official report to division headquarters, his words reflecting genuine amazement at the mechanical transformation. "The American fuel has revolutionized our operational capabilities. We can now match German tank units in speed, endurance, and tactical flexibility. Our combat effectiveness has increased dramatically." Sergeant Rossi, whose mechanical expertise made him the company's engine specialist, examined the improved engine performance with professional fascination. "These engines are producing power levels I never thought possible," Rossi confided to fellow mechanics during their evening maintenance procedures. "The fuel has transformed machines I thought were reaching the end of their operational life. If this performance continues, we can extend our combat operations indefinitely." Tank crews conducted extended training exercises to test their improved capabilities, pushing their vehicles through demanding tactical scenarios that had been impossible under previous fuel limitations. The enhanced performance enabled complex maneuvers, extended patrol operations, and aggressive combat techniques that significantly expanded their tactical options. But on the morning of September 18th, precisely 72 hours after the first tanks had been refueled with captured American aviation petroleum, the celebration turned to horror with a mechanical disaster that defied comprehension. Private Franco Bianchi was performing his routine morning maintenance inspection on his tank when he first noticed something deeply wrong with the mechanical systems he had maintained so carefully throughout the campaign. An unusual metallic grinding sound was emanating from the engine compartment, a harsh scraping noise unlike anything in his experience with Italian armored vehicles. The sound had a desperate dying quality that filled him with dread at the recognition of impending mechanical catastrophe. Within minutes, the grinding sound escalated into a violent mechanical screaming that could be heard across the entire camp, a metallic shriek that brought every tank crew running to investigate the source of the terrifying noise. The sound was unlike anything these experienced mechanics had ever encountered, not the familiar rattle of worn bearings, not the grinding of damaged gears, but something far more sinister and destructive. When Sergeant Rossi removed the engine cover to investigate the mechanical distress, he discovered a scene that defied his decades of mechanical experience and challenged everything he understood about engine operation. What he saw inside the engine compartment violated fundamental principles of mechanical engineering and revealed a level of mechanical destruction that seemed almost supernatural in its completeness. The engine's internal components were dissolving before his eyes. Metal surfaces that should have been smooth and precisely machined showed evidence of severe chemical corrosion, as if acid had been poured directly onto the engine components. Aluminum parts, which formed critical structural elements of the Italian engine design, were literally disintegrating under the influence of chemical reactions that Rossi could not identify or understand. The destruction was not mechanical wear from normal operation, but chemical dissolution that was consuming the engine from within. "Mother of God," Rossi whispered, his voice barely audible as he stared into the ruined engine compartment. "This is impossible. Engines do not destroy themselves like this." The specialized additives in the American aviation fuel had initiated complex chemical reactions that specifically targeted Italian engine materials and design characteristics. The corrosion was not random mechanical failure, but appeared to follow metallurgical lines that suggested deliberate chemical engineering designed to exploit specific vulnerabilities in Italian tank construction. Aluminum engine components, which Italian manufacturers had chosen for their lightweight and cost-effectiveness, proved particularly susceptible to the chemical additives in American aviation fuel. The tetraethyl lead compounds, designed to enhance aircraft engine performance, created galvanic corrosion when combined with aluminum alloys used in Italian tank engines. Anti-icing agents meant to prevent fuel line freezing at high altitudes. Instead, degraded rubber seals and gaskets in ground-level applications. The chemical destruction followed predictable patterns that suggested scientific precision rather than random mechanical failure. Fuel injection systems clogged with metallic deposits, cooling systems failed as rubber components disintegrated, and engine oil became contaminated with chemical byproducts. Tank after tank began suffering catastrophic engine failures as the chemical reactions progressed through their mechanical systems. The destruction was systematic and complete, affecting every engine component that came into contact with the contaminated fuel system. Pistons seized in their cylinders as chemical corrosion created friction surfaces that could not be overcome by normal engine power. Fuel pumps dissolved from chemical corrosion that ate through metal components designed to last for thousands of hours of operation. Private Bianchi, whose petroleum industry background should have prepared him to understand fuel-related problems, stood helplessly beside his destroyed tank engine, unable to comprehend the chemical processes that had eliminated his vehicle's combat capability. "This fuel has poisoned our machines," he said, his voice filled with confusion and despair. "I have never seen chemical destruction like this in civilian petroleum work. Within 72 hours of the first refueling operation, 26 of the company's 30 tanks were completely inoperable due to catastrophic engine failure. The mechanical carnage was so complete and systematic that it clearly indicated deliberate sabotage rather than accidental contamination or random mechanical failure. American chemical engineers had developed fuel that would enhance their own aircraft, while simultaneously destroying enemy ground vehicles through chemical processes that Italian engineers had never considered." Benedetti watched his unit's combat effectiveness evaporate before his eyes with the helpless horror of a commander, witnessing his command destroyed by an enemy he could not identify, locate or engage. Tank commanders who had celebrated their good fortune just days earlier now stood helplessly beside smoking, ruined machines that represented months of training, maintenance, and combat experience reduced to useless scrap metal. The mechanical carnage was so complete that even Rossi, with his vast experience maintaining Italian armored vehicles under impossible conditions, declared most of the engines beyond repair, using available resources and replacement components. The chemical destruction had penetrated so deeply into engine systems that even complete rebuilding would require metallurgical expertise and chemical knowledge that exceeded Italian field maintenance capabilities. "Captain, this was no accident," Rossi said grimly, examining the chemical residue coating a destroyed engine block. "The Americans designed this fuel to destroy our machines. They knew we would capture it. They wanted us to use it." The revelation struck the Italian officers like a physical blow. The Americans had anticipated Italian forces would capture and use their abandoned fuel supplies. Rather than simply destroying their petroleum before retreating, they had left behind chemically sabotaged fuel that would eliminate enemy armored capabilities far more effectively than any direct attack. This was industrial warfare at its most sophisticated level. American chemical engineers had developed fuel additives that would enhance their own aircraft while simultaneously destroying enemy ground vehicles. The fuel that had seemed like such a precious prize was actually a precisely engineered weapon, designed to exploit Italian desperation and mechanical inexperience. Lieutenant Moretti, the officer who had discovered the fuel depot, sat in stunned silence as mechanics confirmed the extent of the damage. His tank, which had performed so magnificently for 3 days, now leaked chemical sludge from every mechanical opening. The engine that had roared with power was now a corroded mass of useless metal. "They planned this entire scenario," Moretti said, his voice hollow with realization. "They knew our fuel situation. They knew we would take whatever we could find. They turned our desperation against us." The psychological impact extended far beyond the immediate tactical disaster. Italian tank crews had prided themselves on their mechanical ingenuity, their ability to keep machines running under impossible conditions. Discovering that their enemies possessed such sophisticated technical capabilities shattered fundamental assumptions about their own competence and resourcefulness. Captain Benedetti faced the impossible task of explaining to his superiors how an entire tank company had been eliminated, not by enemy fire but by their own decision to use captured fuel. The official report required careful language to describe a defeat that highlighted Italian technical vulnerability and American industrial supremacy. Enemy forces employed advanced chemical sabotage techniques against captured petroleum supplies, Benedetti wrote. Specialized fuel additives designed for aircraft engines proved incompatible with tank engine systems, resulting in complete mechanical failure of affected vehicles. The incident exposed critical differences in industrial sophistication between American and Italian military capabilities. While Italian engineers focused on basic mechanical reliability, American chemists had developed highly specialized petroleum products that served dual purposes as both performance enhancers and potential weapons. German technical advisors, when they learned of the fuel sabotage, expressed grudging admiration for American engineering ingenuity. Colonel Heinrich Müller, attached to the Italian Ariete Division, examined the destroyed engines with professional interest. "This represents industrial warfare at its most elegant," Müller observed. Rather than wasting resources destroying fuel depots, the Americans created fuel that would destroy enemy equipment from within. It demonstrates their understanding that modern warfare requires technical sophistication, not just military courage. The fuel sabotage incident became a classified case study within Italian military engineering circles. Technical officers studied the chemical breakdown of the destroyed engines to understand how American additives had achieved such complete mechanical destruction. The analysis revealed a level of chemical engineering expertise that Italian industry could not match. Sergeant Rossi, whose mechanical expertise had made him invaluable to the tank company, found his confidence permanently shaken by the fuel disaster. For months afterward, he approached every mechanical problem with paranoid caution, suspecting chemical sabotage in every unusual engine symptom. "Before this happened, I thought I understood machines," Rossi confided to a fellow mechanic. "Now I realize there are technologies beyond our comprehension. The Americans fight with chemistry we cannot even identify, let alone counter. The broader implications extended throughout Italian forces in North Africa. Units became reluctant to use any captured Allied equipment or supplies, fearing additional examples of technical sabotage. This paranoia, while sometimes excessive, reflected accurate assessment of American industrial capabilities and strategic thinking. Intelligence reports from other sectors confirmed that the fuel sabotage was part of a systematic American program. Chemical engineers working with military planners had developed numerous products designed to appear valuable, while actually damaging enemy equipment. Aviation fuel was just one example of industrial warfare techniques that treated manufacturing itself as a battlefield. The tank company never recovered from the fuel disaster. Replacement engines were unavailable due to Italian industrial limitations and German supply priorities. Most of the affected tanks were cannibalized for spare parts, leaving Benedetti with only 4 operational vehicles from his original complement of 30. Lieutenant Moretti, traumatized by his role in the disaster, requested transfer to infantry service. The young officer could not reconcile his military training with the reality of technical warfare beyond his understanding. His final report to division headquarters captured the psychological impact of the fuel sabotage. Traditional military valor becomes meaningless when the enemy possesses industrial capabilities that transform our basic necessities into weapons against us, Moretti wrote. We are fighting an opponent who thinks in dimensions we cannot comprehend. The fuel incident marked a turning point in how Italian forces understood their position in the global conflict. They were fighting not just against enemy soldiers, but against entire industrial systems designed to produce both weapons and counter-weapons. American factories could manufacture fuel that enhanced their own equipment while destroying enemy machines through chemical processes Italian engineers had never considered. Captain Benedetti survived the war, eventually returning to his family's vineyard near Turin, but he never forgot the lesson of the sabotaged fuel, how American industrial sophistication had eliminated his entire unit without firing a single shot. In post-war interviews, he described the fuel disaster as his introduction to truly modern warfare. We thought we were tank soldiers fighting other tank soldiers, Benedetti reflected years later. We discovered we were medieval craftsmen facing an industrial empire. They defeated us with chemistry before we even knew we were under attack. The captured fuel that had seemed like such magnificent fortune became a symbol of the technological gap between Allied and Italian military capabilities. American engineers had turned Italian desperation into a weapon more effective than artillery, demonstrating that industrial warfare required not just manufacturing capacity, but scientific sophistication that could anticipate and exploit enemy behavior. The chemical sabotage program represented American strategic thinking at its most advanced level. Rather than simply denying resources to enemy forces, American planners created resources that would actively damage enemy capabilities. This approach required profound understanding of both chemistry and psychology, anticipating how desperate enemy units would react to apparently valuable discoveries. For the Italian tank crews who experienced the fuel disaster, the incident shattered basic assumptions about warfare itself. They had entered the conflict believing in traditional military values, courage, skill, and mechanical ingenuity. The sabotaged fuel revealed that their opponents possessed capabilities that transformed those traditional virtues into vulnerabilities. The lesson extended far beyond individual tactical situations. Italian military leadership began to understand that they were fighting an enemy whose industrial base could produce not just more weapons, but more sophisticated weapons designed to exploit Italian tactical and technical limitations. The fuel sabotage was merely one example of American industrial warfare capabilities that Italian forces could neither match nor effectively counter. The psychological impact lasted long after the immediate tactical disaster. Italian soldiers throughout North Africa became cautious about any captured Allied equipment, understanding that their enemies possessed technical capabilities beyond Italian comprehension. This cautious approach, while sometimes limiting operational opportunities, reflected accurate assessment of American industrial warfare techniques. The fuel disaster ultimately became part of a larger pattern of technological defeats that convinced Italian military leaders that continued resistance was futile. When faced with an enemy whose industrial base could turn basic necessities into sophisticated weapons, traditional military solutions became inadequate. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II and check out the video on screen for another incredible tale from history. Until next time.